Hi, Robert Cook here. Today I want to do a more advanced conversation around static queries to databases, and it's going to involve a little bit more with AMI script, but you're going to get an idea now of how you can start to blend and run queries across multiple databases, and it's really a very powerful concept that I'm looking forward to discussing. So first off, going to go into developer mode. I can press Control D to get into layout editor mode quickly. I'm going to go to the data modeler. You can see on top of the world database, I've also added another database as well. So these are physically two different databases on different hosts. And now I'm going to go ahead and add a data model on both of them. So normally I've selected one data model. This time I'm going to select both and say add data model. And now I'm going to go ahead and choose two different tables. So we can see the tables show up for both databases inside there. And basically, I know the names of the tables I'm looking for. One is called stocks, and then the other one is called company list. And this, by the way, anytime you see a search box, you can just put a pipe in there if you want to search, if you want to do an or clause or ampersand for and clause. So I'm going to say I want to search for stocks and company. So I've got the company list from the Mint database, and I've got stocks from the world database. Here's a quick preview of that. I'm going to go hit next. So now what we can see is it's actually going to create two tables in our little in-memory database, company list and stocks. One's going to be by executing this query on this data source. And the second one's going to be by running this query on this data source. So this use ds equals world is a way of explicitly setting the data source. This use can handle lots of arguments. You can also explicitly put the limit inside there and all of those other fun things. So I'm going to quickly run that test. We see we get these two tables back. I'm going to go ahead and just replace them to give us a nice shorthand CNS. And now what I want to do is I've got these two in-memory tables, and now I basically want to join them together. So I'm going to say create table joined as select star from C, S, where symbol equals sim. All right, so I'm going to join these two together, and basically on that column and that column. And you can see that we've gotten this one row back. I need to turn off that limit, so we pull in all the data. And now we can see that we've got we've got 2,000 records where they've joined for 3,000 here and 7,000 there. Right. So instead of just doing a simple straight join like this, I could say maybe I want to do something like this. So this is equivalent to that straight join I did before. But now instead maybe I could say left join. Right? So this is going to give me all the records that exist in one table but don't exist in the other table. Okay, so basically, or I should say left only join, sorry. There we go. Now we've got the 928 records that exist in the left table but don't exist in the right table. So this is a very quick way of doing recon or something along those lines. But here's something else that you can do where this starts to commingle with the Java part of things. So let's say I just want to get the number of records that exist on the left and don't exist on the right. Well, I've created this table joined as ... Right? Now I'm going to say int count equals select count star from joined. Right? So we're going to run this query. It only returns a single value. So basically we can take that value and then stuff it into a local variable. And then I'll just go ahead and do a session.alert on that. And then we'll see what that count is. So test that query out, 928. And now we could do something more interesting inside here. So let's say we run this, and if the count is greater than 1,000, hypothetically, we could go ahead and run another query in another database or something else like that, or we could do a session.alert. So we can basically put whatever sort of workflow we want inside here and run further queries, as an example. Now let's say hypothetically instead, we want to get a list. We want to get the symbols that exist on the left and not on the right, and we want to just put that into, let's say, a list. Right. So first off, by the way, if you want to create a list, it would be something like this. List, my list equals new list, A, B, C. So this is an easy way to create a list inside our language. Session.alert, my list. Okay, test that out. So ABC. But what I want to do instead is say my list equals select symbol from joined. Okay, so this is now going to run this query, which returns a single column, and because it returns a single column, I can assign it to a list. So I'm going to hit test, and now we're going to get back an alert which has a list of all those symbols. So you can imagine you could start to do interesting things. I could loop through those symbols and run additional queries. I could take all those symbols and mash them together into a string, and then maybe run some in clause or something like that on it. So this concept allows you to quickly go back and forth with the string templating and the ability to take the results of queries and assign them to variables. It allows you to very easily go back and forth between SQL and higher level languages like Java. So I think this is a good example of how you can do something like that. And it goes without saying that, not only can you do joining on this data, if I wanted to, I could union data. So if I have lots of different data sources, I could query them, put them in a for loop perhaps, and then I could join those tables together, et cetera, et cetera. So this is a good example of how I can basically build pretty advanced analytics on that stuff. And by the way, so now that I've created 3 tables inside here, I'm going to go ahead and comment that out. I'm going to say now, finish this off, and now I've got this one data model. It's called multi because we're hitting multiple databases. And now if I said window, new window, and I said create a table visualization, if I chose this multi, it's now going to ask me which table do I want to use to represent that. Joined, choose table, click on that, finish, and now we can see the data. So this is that join data. So actually this is the data that exists in the one side but not in the other. So that's an example of how to do that. Now, an interesting thing here is tables actually are only backed by a single table. That logically makes sense. Charts, on the other hand, can actually sit on top of multiple tables and multiple data sources and all that fun stuff. That's out of the scope of what we can cover today, but it is worth noting. Also, I mentioned this before, but when you create relationships, you can actually define multiple variables. That may be important if you want to basically have different where clauses for the different queries you're going to run against the various databases and tables. So you might have where and then where to, and then basically when you define your relationship, you can have the where and the where to formulated different ways. Okay, so another thing I wanted to cover today, last thing, is the ability to basically run a query against a data source and then copy that into our in-memory database, where you can kind of think of it as being cached. So as opposed to statically querying this data source all the time, you can basically cache it inside our database. So the first thing I'm going to do is go ahead and start up a PuTTY session, and I'm going to go to our local host. And I talked about this in the real time. So I'm going to go to localhost 3290, and that's going to basically open up a database port. I'm going to go ahead and log in again. And now I'm going to go ahead and say show data sources. And what's interesting here is you'll actually see that those data sources, world and mint, show up inside this table, and then we've also got our in-memory database. So just like I can do inside the data models, I can run queries here as well. So I could say use data source equals mint. I'll do use data source equals world, execute select star from country. Okay, so this basically is going to run that query. Use execute select star from country. There we go. So this actually ran that. And by the way, that error we got, that's coming back from MySQL, because MySQL didn't understand this query that we ended up sending off. So I'm going to go, so I run that. All that data comes back, just goes on the screen. But actually what I want to do instead is I want to put it inside an in-memory table that we can then use. So I'm going to say create public table as, and then use ds world equals yada yada yada, and I'll call this maybe my country instead. So now if I do show tables, we're going to see that there's this in-memory table called my country, right? And if we're not going into persistence and all this stuff today, but if we did that, then it'd be persisted to disk. But now I can build visualizations on that instead. So I could say add data model to AMI, and then basically now we see this my country shows up. I hit next, and then I hit test. And now this actually is querying our in-memory database instead of going directly to the MySQL database. So we could now set up, like timers or something like that to periodically go ahead and sync this table up. And I should mention just one more command, which is sync. So basically, sync table my country from there we go. Sync my country from use world. So this basically is now syncing that table up. So it's running this query. It takes the results and syncs that up, right? So basically it's doing updates and all that. And so this is a good way of setting up caching as well. So I think that's good for today, and look forward to talking again. Bye.